moving on from or rather building on what we did last week, right? We sort of ran the gamut on a lot of very fundamental ideas about Grasshopper form generation, right? So we looked at subdividing panels, we looked at reparametrizing their boundaries, we looked at rotators, we looked at cull patterns. I threw a lot of stuff at you. And do you know how to use it? Do you know how to make something of your own using any of those principles? It's okay, you can answer honestly.
No.
No, you don't, right? So the attempt was to give you a few things to sort of mull over, and if you needed to for your design project, you could pretty much copy and paste it into your design project and graft it on, and it would work for now. When it comes to your final project, you'll have to probably design something that's very different than that. And so what I'm going to do is kind of go back to fundamentals here. We're going to look at the structure of lists, the flow of data, how to modify it, how to isolate it, and really use it to your advantage. So the first thing, sorry, I'm getting confused here where my stuff is. The first thing that I wanted to do is an exercise that helped me a lot, and it actually came from this guy called Nick Sensky, and if you look on my YouTube channel, he's the only person, at least right now, that I'm subscribed to. He's a professor at UNC Charlotte, and his work is very, very clear, and it's very fundamental. It's a lot like the way that I teach my class, and it's not just because I learned it that way. It's because I think it's very effective. So outside of this course, if you want to learn a little bit more, you can go to his. He has pretty much all of his actual coursework up online, just like I do, except his kind of comes in like full classes. He does like hour-long videos, whereas mine are chopped up. So anyway, what I'm getting at is the idea of patterning, right? So patterning is not just bunches of circles of different sizes, right? You have to understand the structure of information that defines what a pattern is. And so one of the things that I quickly want to kind of go over with you is the simplest form of pattern in its abstracted form. So we're going to apply circles to a grid, essentially, right? So the grid is just a bunch of points in space. So for us, real quick, what we're going to do is go into vector, and we're going to go into grid type here, and we're going to look at, I guess for now, a square grid. And this square grid is going to require, it's fine if you want to leave the plane at the origin point, that's fine. But it's going to require a size for the grid cells and an X and a Y value to determine how many cells there are. So the size, because I'm working in feet, I'm going to probably just put in like 1 to 5. I don't know, 5 feet might seem like a reasonable grid size. So I'll say 1 to 5. And in fact, actually, I copied those down, but I don't think I want to. I'm going to make a slider here with probably 1 to 10 for my count. So I can increase, let's see. Why can't I see it? There we go. All right, so yeah, so increase the count, and you'll see that your grid is now kind of growing from the origin, however many your count reads. Making some sense? Okay, so right off the bat, I want to first show you point lists and how the points of these outputs are being read. Okay, so I mentioned before, and I showed you under display, you have the option to read a point list, or you can visually see the order. So let's take a look at that just as a means of helping you learn to identify how information is being read. So I'm going to go to point list, and I'm going to also bring in point order, and it's going to help us see how they're being read. So we have cells and we have points. being output from this grid, right? So obviously the cells are the empty spaces in between, and the points are going to be at the intersections. So if I plug in, let's start with the point list option. If I plug in the points at the grid corners into the P input of my points as a list, I can go drop in a slider here. Let me make it a little bigger here. I'm just going to say 1 to 5 maybe. I don't know what kind of scale we're working at here, but bump this up. There we go. So I can read the list of points as they are in a visual means, right? So I showed you this once before, but I didn't explain it in excruciating detail, and now I am. They are read in packets of information. And let me just be very, very clear that when you're dealing with a simple grid, what it's doing is it's reading through the square grid node in order, if that makes any sense. It's going by, all right, so you gave me the cell size, and now you gave me the number of x values. And just like your Cartesian coordinate system logic, the x value is first. It goes 0, 0, 0, 0, 0, 0, because I gave it 5 items, which, you know, in an it is your 5 spaces, not 5 points. Is that making sense with you guys right now? So the x value came first, the y value comes second, and that's where it's saying, well, I have each of those x value packets, I have it as a set. And that set is being multiplied 7 times in the y value direction. So that's why you're getting index item 0, 0, 0, 0, 0 6 times, and then 1, 1, 1, 1, 1, and then 2, 2, 2, 2, 2, and then 3, 3, 3. And if you plug in a panel, you'll see those listed here. Okay, so I'm not going to expand the whole thing, but this first packet of information is, if you look at the top right corner here, right here it says 0, 0, 0. That's your 0 index item list. So the point right here at the origin is 0, 0, 0. The point, oh, okay, sorry. So it's reading it, yeah, sorry. It's reading it this way. And where's the 5? There it is. So the 0. See how it's index 0 here? So the first item is index 0 of the next set. So that's going to be 5, 0, 0, because we set our grid cell size to 5. Okay, so that is all of the index item zeros of each of your packets of data. So then the actual set is a set of 7, and it's reading 0, 1, 2, 3, 4, 5, 6, 7 all the way up to here. Okay, so is that making some sense? So the other thing that we can do, and I actually never really used this before, but we can reverse it by going to flip matrix. So if for some reason you have a pattern that's directionally dependent, right, and you need to switch it to turn the other way, flip matrix is going to modify the data in, oh, whoops, I chose the wrong one. Flip matrix. Okay, so it's going to modify the data and swap your rows and columns. So if I plug my points into that, and I plug that into my panel now, you see that it's going to read it a little differently. Now the x value is grouped in a packet of 6, so it's going 0, and then 5, and then 10, 15, only in the x direction. So if the flip value is what I plug in to the point list, now you see that my zeros are going that way, and my 0, 1, 2, 3, 4, 5 is going this way. Brilliant, right? Does that clarify a few things? It might not yet, because we haven't actually built anything off of it, but it's very, very important, and you'll see why in a few moments. Okay? No questions? You guys need to start asking more questions. Yeah.